So, hey everyone, my name is Afonso, and the name of my talk is React Hooks broke my tests. Know what? So, before diving into the talk, I'm going to introduce myself. As I mentioned previously, my name is Afonso, and I'm a software engineer, part at Talkdesk. I'm part of the Innovation Lab here in Coimbra, Portugal, and you can find me on Twitter and Medium, with the handle you can see there. So, what is this talk about? What am I going to talk to you about on the next couple of minutes? So, this is a story about a migration to React Hooks that showed us that our tests weren't actually done as we expected, yeah. So this forced us to shift our mind process and approaches to how we built and created our tests. And during this process, it led us to get it introduced to React testing library and everything that it surrounds in this case. So I'll do a dive into the whys of migrating from Enzyme to React testing library, and then I'll do a small guide and show a couple of things of the React testing library, which will be the base for you to start building your tests afterward. And by the end, I'll show a couple of mistakes and issues we have encountered during these months we have been using the React testing library. So to give you all some context, the story takes part in mid-2019, and we had a fairly new React Redux project, which used Enzyme for our tests. At this time, React Hooks had been around for a couple of months, we made a decision and said, okay, we are going to start use React Hooks on our application. So it was a thing that was questioned at the time, and for that, I have a couple of answers. So before reading what's there, it's important to mention that hooks are the direction that the React team has publicly announced that they intend on taking React. So this would acted as the first motivation for us to do this migration and starting using hooks, and as well as the project was fairly new. Other motives we had was the code readability. So before lifecycles, before hooks, we had lifecycle functions, and lifecycle functions are great, but they would often get crowded with unrelated code together, and this would bring a major hit to our application readability. With React Hooks, we have effects, and we can split our code through each effect, and the logic will be coupled together. And we can also have as many effects as we want for the type of logic that we need inside of them. The other topic that made us move to hooks was the code reusability. So before hooks, there was no way to reuse stateful logic between components. Well, we had mixins for a while, but they were deemed unsafe. And then we have patterns like I order components or render props. But usually these patterns come at the cost of needing to restructure our components or adding extra complexity. So now with hooks and custom hooks, this is possible and so much easier. So the last reason of why we decided to migrate to hooks was, at the time, and at Talkdesk, we would be soon hiring some junior developers, and we wanted for their onboarding and ramp-up process to be as easy and smooth as we could. And by introducing them to hooks from early on, this would mean we wouldn't have to worry about teaching class components, even though they might wear them afterwards, but we wouldn't have to worry about it. We wouldn't have to worry about explaining how this works from the start, why should we bind our events. And given all these reasons, we started to work and migrate our code to React Hooks. So this is an example of us furiously typing and migrating our components. And, it suffices to say that the migration was successful. Everything, not everything, but what we expected worked well. And our code was working as it was before. We had more than enough of the lines of code we had in the past. well, we thought everything was going well, so does someone remember, okay, have you run the tests? And, well, this happened. But more than half of our tests were failing at the time, and you could probably imagine that this was our reaction. So this made us wonder, if we change our components to hooks, everything is working as it was at least in the code part, and on what we can see, why aren't our tests reflecting the same thing? So we went to research and researched a little bit more and hit with the head on the wall a couple of times more until we find out the guilty part. And that was testing implementation details. So you may be wondering, what are implementation details? And by the words of Kansi Dots, implementation details are the things which the users of your code will not typically use, see, or even know about. So in this case, on our tests, a thing that may be implementation details is for instance, the component state. And at the time, we had a single objective. So we probably have to shift the way we are doing our tests. By testing implementation details means that every time we do a refactor, we'll have to rewrite our tests again. Then maybe we should change them. So we did some evaluations until we met the React testing library. And one of the perspectives that we loved from the React testing library was the ability of testing our components in the exact same way that the user interacts with them. So with this perspective at end, we were pretty sure we wanted to stop using Enzyme. And, well, you might be wondering, but why move away from Enzyme? Don't you like Enzyme? Does it have something wrong? Well, the thing is, Enzyme is great, and I love it. I support everyone that uses it. But the thing here is, for you to use Enzyme, you have to be aware of from the start, you have to be aware of what mistakes you can make early on. Because Enzyme is great, it supports a huge amount of tools to test our components. The thing here is that many of these tools encourage testing implementation details, even if accidentally. And other things, like for instance, a shallow rendering, also have their part into the why I personally decided to stop using and rendering and doing shallow rendering, because for those of you who don't know, shallow rendering basically takes your component and renders a shallow part of it. This means that you will only see the shallow part of your component. In this case, you won't see the component children. And this is not the way that a user interacts with your component. When a user interacts with your component, it will interact with what it's on the shallow part and every child of the component. So this was one of the things why I personally disliked Enzyme, but it's still great. Another thing that, oops, the slide is not passing. Okay, now it is. Another thing that Enzyme has, which is great if you do it properly, it's the find function. Find is the function that Enzyme offers you that allows you to provide a way to query your elements on the DOM. The main issue here is that supports finding by class or by ID, in this case, or by component name, and this doesn't reflect the way that the user searches and finds an element on the page. And lastly, the thing which is probably the worst implementation detail, in my opinion, which is the state. We had a lot of tests attached to the state, and the thing here is we should assert and we should validate that things work by the way they look on the DOM and how they react to events we dispatch on a DOM, and not by what it's doing inside. We shouldn't worry about if my state is 10 or it is 11 at a certain point. What we should worry is what it's doing right now and what we'll do on depending on an event in this case. So, as I mentioned previously, one of the reasons for us to move out of Enzyme was the testing library, and with the testing library comes its main guideline, which you can see from this tweet, in this tweet from Kenzie Dots, which some of you may or not know. The thing here is, the more your tests resemble the way your software is used, the more confidence they can give you. So for those of you who don't know Kenzie Dots is the author of the DOM testing library, which is the base from where the React testing library is built upon. So now I'll be speaking a bit and showing you some examples of the React testing library. So here we have a snippet that shows a typical test while using the React testing library. So first, we import what we need for our test. In this case, we are importing the render and the fire event. We describe our test, and then we say, okay, I want to render my component into a container, which will be appended to the document body, and then I want to query something. So the render will return me a function that will allow for me to perform a certain query. Then, after that query is done, it will return me the input I'm expecting in this case, and afterward I can fire some events or something else. And lastly, we do the assertion. So this is one small example of a typical test, and now I'm going to break each section of this test into small parts, starting by the render. So the render is a function that will render your component into a container, which will be appended to the document body. This render function will also return you a bunch of utils, and as well as queries, which you can use on your tests. And it's about queries that we're going to talk now, next in this case. So what are queries? In this case, queries are the way that we can query the DOM for some nodes. And the base variants on the testing library are the ones you can see here. We have a query by query, which will return the first matching null or node, or return null if you don't find what you're looking for. You have a get by query, which will do the same, return the first matching node, but with a small nuance. In this case, it will throw an error if it doesn't find the element you're looking for. And then we have our asynchronous query, which is find by. This is a query which will return a promise that will resolve when it finds the matching node, or will reject if there is no match. All these queries support an all by variant, which will allow us to, instead of getting only the first matching node, to get an array of all matching nodes. So, a question that I often hear when writing tests is, which query should I use? And the answer that I usually give is, your queries should focus on the way that the user interacts with your components. So what I mean by this is, you should use queries that reflect accessibility in this case. So the React testing library queries are divided into 4 categories, which are the queries accessible to everyone, the semantic queries, the test ID queries, and the manual queries. Usually, you should give priority to the queries accessible to everyone, and then only if these queries aren't possible to use, you should go down this ladder. So I'm going to show you a bit more about each type of query. So starting off on the query accessible to everyone, we have there are the queries that reflect the full experience of a visual or mouse of assistive technology user. These queries are queries like by label text, by placeholder text, by role, display value, or by text. And this should be always prioritized related to the others. Why? Well, let's dive into the semantic queries. These are queries that make use of HTML5 and ARIA compliant selectors. And the queries that are grouped in this category are the by alt text and by title. And this shouldn't be given the same priority as the previous ones, because the user experience while interacting with these attributes, in this case the alt text and title attribute, varies greatly across browsers or assistive technology. So this is the actual reason why I say only use queries that are not accessible to everyone if you have no other way of using them. I'll be showing you an example of a query accessible to everyone, which in this case is the by label text. Yeah, exactly. So how does this work? Firstly, we render our component, as I shown previously, and then the render will return a bunch of utils and the queries. In this case, we can destructure the query we want. We destructure the get by label text. We could also destructure the query by label text or find by label text if we wanted to do some asynchronous query. And in this case, I'm using the get by label text. And what I do is, okay, I want to get the input or the element that is associated with the node that has the username. So what it will do is it will go look into it. It'll see, okay, I have this label which has username into it. The ID is username label. It will find that the input down is associated as the same ID, and it will return this input. And then we are ready to do some events, or dispatch some events or anything else. Going into a semantic query example, here we have a get by title query. These are in this case, remember when I told you that the user experience varies across browser or assistive technology? Well, in this case, it's important to mention that the title attribute by default is not visible for sighted users. You have to do some tweaking around to be able to see them, and it's not consistently read by screen readers. The syntax and the behavior, it's exactly the same as the previous one. We render our component, we destructure our query, and then we get to the querying part. So now we get to the test IDs and manual queries, and this should be the last type of queries you want to do because they reflect implementation details. So what I mean here is that usually, not usually, users don't care about test IDs. Users don't care about classes, and you should avoid these queries unless you really have a strong motive to. And if you have a strong motive, you should give priority to test ID queries, because in this case, this is a custom real query which is exported by the testing library, and in this case we are actually using the query selector DOM API, and this is an escape hatch as it opens up ways to query the DOM for classes or for attributes and any other things. So the behavior, it's the same as above. So you may be wondering what's usually the use case for a test ID. Let's imagine that we have a text that is dynamic, and then we have no other way from getting it. The by role doesn't work. The by placeholder text doesn't work. Usually, this is a case where we should go to a test ID query. Here we are using a data test ID attribute, which is the default one, but this can be configurable for whatever you want. The testing library exports an helper called configure, which allows you to configure the data attribute which will be used when you are using the get by test ID queries. And as I mentioned, the manual query, in this case, what we do is the query selector DOM API. So I've shown you all the queries we have on the testing library in this case and did an example for each of them. I'm going just to give us a special use case, which is in a certain case that you need to build a custom query. The React testing library exports a build queries helper, which allows you to create the queries that you want. It's just important to refer that if you choose to follow this approach, you should you should build your queries in a user-centric way and without focusing on implementation details. So I guess now that we have dealt with render and with queries, let's see how we can dispatch events using the testing library. So the first example we have is the fire event. The fire event is the way that the testing library offers you to fire a single event into a given element. In this case, we are doing a change event, and we are saying, okay, get me the the element that has a text box role, and then I want you to change the value of it. If you don't want to use fire event, you have the user event library that will allow you to do the same. Not the same actually, because it has a difference. When you're using fire event, you're only firing a single event, and this doesn't reflect the real way that the user interacts with your elements. For instance, when you click on a button, when you go click on a button, there are several events that are dispatched during that time. You have the on mouse enter, you have the on click, on the mouse leave, and this is the exact use case from where the user event library was built. In this case, it will simulate all the events that are usually associated with the typing, instead of just doing a value change. Generally, you may not need the user event library. Until right now, I didn't have a use case where I needed it, but it's pretty great. And if you really want to get the extra confidence and go the extra mile, then you should probably use it. So now let's imagine that we want to wait for things. Well, React Testing Library allows you to do that as well. It supports these two asynchrotils, which is the wait for function and the wait for element to be removed function. The wait for function receives a callback. In this case, it's receiving an expectation, and that callback will be executed every time until it passes. So what this example will do is, okay, it will run our test. It will say, okay, is this query by label text loading not in the document already? It is, so let's render it, let's do it again and again and again and again until this assertion becomes true. This is usually great for waiting for stuff that haven't happened and will happen on your test. In case you only want to wait for a certain element to disappear, so you can do other actions, you can use the wait for element to be removed function, which takes an element or a callback and it will wait until it no longer is in the DOM. So I believe I've mentioned all the use cases and I've shown you everything that you may need for writing your tests, but just in case, here are some helpers. I'll be starting with the within. Within is a function that receives an element and basically allows you to do a query inside of that element. So generally, when you do a render, when you're doing a query that comes from the render function, you're executing that query on the container that the render function rendered. And within, you can go down the ladder in this case and do only inside the element you want. The screen object, it's a way that the testing library offers you for being able to do global queries. Because most of the cases, you don't need to destructure render and you just want to do a query which will be global anyway. So in these cases, you can use the screen object, which has all the default queries binded and allows you to do them instead of destructuring them from the render. And the last helper I'm going to show you, it's the debug. So debug, it's pretty useful when your tests are failing and you don't know why. And basically what it does, it's do a pretty version of the DOM on your console. If you don't pass it any parameter, it will log everything. But if you pass it an element, it will only log the specific element. For convenience, that debug function was also exported from the screen. So let's jump to today. Oops. And we have been using the React testing library for months. And personally, I have never been happier with the way I write my tests. They are free of implementation details, and I can guarantee you that they won't break with any non-feature removing refactor, unless there is some actual mistake you haven't considered previously, but they are pretty safe, basically. So before finishing this talk, I'd like to show you some mistakes. we have made during the past months of using the React testing library. So here they are. I'll be starting with the using act. So some of you may wonder what act is. Act is an helper that the React team offers you for when you're writing tests. Basically, imagine that you have tasks like rendering or user events, doing some user events or doing some data fetching. Usually these tasks are what are called units of an interaction with a user interface. So Act is an helper that React provides to you that makes sure that all these updates are finished and been committed to the DOM before you do any assertions. So if we are following the examples we see and use Act, this would be probably something we would do, because render it's a task that will be considered as a unit of interaction. A fire event, it's the same thing. The thing here is we don't need to do this, because the React testing library wraps all of our functions and utils we use on our tests with Act. So basically, we don't need to use it. Another thing that I've often seen, and that some developers usually are eating their heads of why this isn't working, is using getBy with expect not to be in a document. So as I mentioned previously, a getBy function will throw an error when it doesn't find the node you're looking for. And if we are trying to use a getBy query to assert that something isn't in a DOM, well, this test is doomed to never pass. So instead of that, we should use the query variant, which will return null when it doesn't find the node we are looking for. And in this case, this test will pass and you won't have issues. Well, it will pass if the actual element isn't in a DOM. Another thing I've often seen is using await with fire event or non-asynchronous queries. So as I mentioned when I spoke about the queries, the only queries which are asynchronous are the find by variants. So you should only use await with those variants. And some people have often seen examples of using await with fire event, but usually what this means is that they are looking at the Vue testing library docs, because the only library where the fire event is asynchronous is on the Vue testing library. So the solution for this is stop using asynchronous stuff and awaiting for stuff you don't need to await. Using await, wait for, with an empty callback. So when I spoke to you about wait for, I mentioned that it takes a callback that will wait until it passes to go to the next statement. Well, in this case, if we pass it an empty callback, what this will do is wait until the next tick of our test and then continue on with its life. As this may work sometimes, it's not the way it should be used, because by passing this and by waiting for the next unit of our test, it doesn't generally guarantee us that our expectation or assertion will pass when we need it to. So instead, we should use it as it should. We should pass an assertion inside of our wait for callback and do it this way. And the last mistake and issue that we did was using cleanup with the after each. So it's usually best practices to clean up after yourself after each test, and you may often get into the case you might do this. Well, the thing here is, if you're using a framework that supports the after each global, like Jest or Jasmine, then the React testing library will already do that automatically for you after each test. So you don't have to go cleaning up after yourself unnecessarily or doing duplicate work. So with all these mistakes and issues, here are a thing that helped us fixing them up and catching them earlier, which is the SLint for the plugin testing library. This is pretty great and has a bunch of best practices that you can use and customize to your needs. And well, who doesn't love some static analysis on their tests? So with this, I conclude my talk. it's just important to refrain and going back into a perspective that, well, actually the issue was not the React hooks. React hooks didn't actually break our tests. They only showed us that we weren't testing how we should. We were focusing on implementation details and not on how the way the user interacts with our components. Since I've started using the React testing library, I actually am happy when I have to write tests, which was a thing that I actually usually didn't like when it got to the time to, oh, wait, I have to write tests. No, I don't want to do it. But, well, now I love to write tests. And a thing that I also really like about the React testing library, which are the queries, because by focusing on the accessibility first queries, we often end up finding some accessibility issues on our components. I usually start with the mental process of, okay, let's use a get by label text. Okay, so but why can't I use a get by label text? And then I often go back to my component and be like, oh, okay, I didn't put the ID here. And the React testing library also, with what I mean here is that it usually allows me to write more accessible components without me noticing that I'm doing it. So, as I conclude my talk, I hope everyone enjoyed. You can find me on Twitter at this handle, and if anyone has some questions, fire away.
So it's funny, I'm actually in the middle of creating a hooks library myself, so I'm going to be running into testing that entire library very, very soon. So this is super enticing.
Yeah, and for those of you who are writing your own hooks, you also have the React hooks testing library, which is great for use cases where you have huge amount of logic you have to really test from an implementation perspective in this case. And
right. Yeah, it's perfect for that. I actually just saw a friend of mine built a hook for Stripe carts and had used the render hook utility from React hooks from testing library. So super excited to get started on that. Daniel, thank you so much for talking. Your talk was amazing. I know people in chat got something to think about. Thank you so much for coming out.
Thank you for having me.
See you later.
See you.